All right, so we have been talking about, can you hear me, Tom? Ionic equations. Ionic equations are where we are given a chemical reaction that follows this trend. Remember this trend? It's AB plus CD, where A and B are both ionic compounds that are aqueous, and the result is AD and CB. And then usually this one, or one of these two over here, becomes solid. Okay? So, an equation that follows this pattern, again, A and B and C and AB and CD are ionic compounds that are soluble in solution, react together. And that's the general equation, and we change it into an ionic equation by taking all of the ones that are aqueous and separating them into their ions, and making sure that the ions have the correct charge and we have the correct number of those ions is essential to write a good ionic equation. So, help me write this second ionic equation for this compound here, or for this reaction here, by telling me what ions I should write down for this ionic equation. Okay?
You should write.
What's that?
You should write Na2.
Na with a 2 down here?
Yes. No, in the front.
Yeah, 2 NAs, right?
And CO3.
Okay, and a CO3. Now I need those charges. What are the charges on those?
Oh yeah, +1.
Positive for the sodium.
And
Talking to the microphone, I can't hear you very well.
carbonate.
Carbonate, what's the ion? What's the charge on it?
Oh. Yeah. -2.
That's right. Now, I also could have known that by seeing that Na2CO3, by seeing that once I knew that this was a +1, I see that there's 2 positive ones, therefore the CO3 must be a -2. So I could look at my periodic, or the back of the periodic table, which is great, but I also could have looked at the compound and known that as well. All right, what's the next one?
Calcium chloride.
All right, very good. So I got a calcium ion and a chloride ion. All right, what are their charges, and do I have the right number?
You need wait, calcium is +2.
Good. Calcium's a +2. We got that from the periodic table.
And chloride is calcium.
Calcium's a +2, right?
You need yeah, that's right. You need chloride is +1. No, -1.
A -1. Very good. All right. Excellent. I've got my periodic table up here ready for whenever we need to look at it. Okay, now, what are the products for this reaction?
CaCO3.
Do I break that up?
No.
No, because it's a solid. That's calcium carbonate. Okay, do I break up the sodium chloride at the end there?
Yes.
Yes, I do.
2 NA.
Very good. 2 NAs.
And 1 chloride.
1 or 2?
1. 2.
Yeah, that's right. Very good. 2 chloride ions. Because that 2 is in front, so it means 2 of both of those. Excellent. That is the ionic equation for that reaction. Very good. So now, spectator ions are the ones that can be removed from the ionic equation because they don't undergo any chemistry. Can you see the spectator ions in this reaction?
Yes.
What are they?
N2Na.
Very good.
Chloride.
Okay, look, I realized something. We forgot to put a 2 in front of that chloride right there, right?
Right.
Because there's 2 chlorides. That's what that 2 means there. I can see that because it says 2 over here and we only had 1 over here. So yes, the chloride ions are also spectators. So then we have the carbonate coming together with the calcium to form calcium carbonate. Okay, very good. So let's look at this reaction up here and get rid of the spectator ions and find out what's left. If I get rid of the spectator ions, what do I have left in this top reaction here? This is the ionic equation here. What are my spectator ions?
Are gonna 2NO3.
Very good. The NO3s aren't going anywhere. And what else? Aren't doing anything?
2K.
The 2 potassiums. That's right. The lead ion comes together with 2 iodide ions to form lead-2 iodide. Excellent. Okay, the next one. Where are my spectator ions?
Oh, 2 chloride.
Good. 2 chlorides. Anything else?
2Na.
2 sulfides, or 2 sodiums. That's right. Very good.
Sodiums.
Excellent. Leaving behind the ionic net ionic equation. So we'll let the folks at home do that one, and hopefully they can get the right answer. This is what the right answer is. Okay. Now I'm going to introduce to you a new class of compounds. It's not completely new. It's more of a subclass. A subclass. And to do this, I want to kind of remind you of what we've learned so far. Okay. If this was a circle that encircled all of the different kinds of compounds that we've kind of talked about so far, we would have in this circle ionic compounds, right? And covalent, which are also known as molecular compounds, right? And what we've learned is that ionic compounds, some of them are soluble. So here we have some ionic compounds that are soluble. Some are insoluble. We've learned that, okay? But we have always also learned that when you put soluble ionic compounds into water, they do more than just dissolve. What else do they do besides dissolve? What's that other word that starts with a D? Dissociate. Dissociate. Very good. Which means the ions actually separate from each other and are surrounded by water molecules. All right? Well, I'm going to introduce to you a new class of compounds. They're molecular, meaning they're made of nonmetals, right? However, when you put them into water, they dissociate. Isn't that crazy?
Yeah.
And we have a special name for them, and it is acids. Acids. All right? So acids are compounds that are molecular, no metals, but when you put them into water, they dissociate. They dissociate. And another characteristic of acids, they always contain an H plus ion, H plus ion. So let's look at an example of one of these acids that dissociates when you put it into water. The acid that we're going to talk about first is HCl, or hydrochloric acid. Hydrochloric acid. When this dissociates, just like the ionic compounds we've talked about, we get an H plus ion and a Cl minus ion. That is dissociation, right? So an acid, again, is a molecular compound that dissociates, and one of the dissociative products is always the H plus ion. All right, that's what an acid is. All right. Some people like to write the dissociation of acid with water around so that they can remind themselves that these ions, specifically this one, is surrounded by water molecules. Surrounded by water molecules. So, for example, if I want to write HCl's dissociation with water, then what I do is I say HCl plus water, and then I take the hydrogen there that's on the Cl, and I give it to that water molecule and make it H3O with a plus sign. And then what's left over is still the Cl minus. Can you see how those two equations are essentially the same, but this one has the water molecule so that you can see that the hydrogen is with the water molecule. Can you see that?
Yeah.
Okay. So HCl is an acid. It dissociates into H plus ion and Cl minus. Usually we can tell that a compound is an acid because it usually starts with a hydrogen ion. Starts with hydrogen. Okay? So, we want to become familiar with these two ways to show the dissociation of an acid. All right? So, I'm going to draw another acid here, HBr. Okay? What will the dissociative products of HBr be when we put it into water? If we put HBr into water, it's an acid. What will be the dissociative products? Talking to the microphone.
H plus Br.
H plus hydrogen ion plus Br. Huh?
Where's bromine at?
It's
Oh,
element
there.
35.
-1.
Yeah, minus. Very good. That's the dissociation of HBr. Now, again, some people like to see HBr with the water molecule, with a water molecule, when it does its dissociation. So how would this be slightly different now?
H2O.
H2 or
3
H3O
plus bromine.
Plus-
-1.
the bromide ion. Very good. So that's the dissociation of acids shown one way with a water molecule and one way without a water molecule. When an acid dissociates, so here I have, let's say, the HCl. The dissociation occurs, the hydrogen ion is there, and it is surrounded by the oxygen ends of water molecules. Right? Just like the sodium ion when it dissociates from sodium chloride. Right? All of the oxygens, because they have the negative, slightly negative charge on them, surround that water molecule. When that happens, because this hydrogen is attached to that oxygen as well, what can happen is a bond can form here. A new bond between a neighboring oxygen can form. And when that happens, this bond here will break. That bond will break. and another water molecule that's passing by will form a bond here with that hydrogen. And then when that new bond forms, this has 3 hydrogens, that bond is going to want to, this bond is going to want to break and form and let that hydrogen go with a different water molecule. And when that happens, this bond forms, this bond will break, right, and form a new bond with a different water molecule. And so that hydrogen ion that's released never stays on one water molecule. It just moves very quickly wherever. And it's not really the same hydrogen ion because water molecule just picks it up and lets go of another one. And then someone else picks up that one and lets go another one. So the hydrogen ion is just moving all over the place. It's not in one spot when we have an acid like that. Does that make sense?
Yes.
Okay, so acids. Acids are molecules that ionize, and when they ionize, they release a hydrogen ion. There are strong acids and weak acids. And just like a strong electrolyte was a compound that dissociated really well, a strong acid is an acid that dissociates completely. If I have a weak acid, like HC2H3O2, a weak acid, that weak acid, it's weak, that means it does not dissociate well. It does not dissociate well. And so we have to draw 2 arrows. And those 2 arrows, one going forward and one going back, are showing that this acid dissociates for a little bit of time, but then it comes right back together. So of all the acid molecules that are sitting in the cup that contains this material, some are dissociated for a little bit of time but come back together. So of all of them, only maybe 1 or 2 for every 1,000 are ever separated. All the rest are together. Whereas HCl, you put that into water, that's a strong acid. That means as soon as you put it in, the H and the Cl separate and stay separated. They never come back together. All right, good. We did a lot of learning today, and we'll pick up from where we stop next time, okay?
Okay.